Hello and welcome to this week's presentation on aggression. Aggression is not a pediatric diagnosis, but rather a symptom of mental health disorders, including oppositional defiant disorder or conduct disorder. Aggression is linked to structural and functional abnormalities in the amygdala, hippocampus, and frontal regions, including the orbitofrontal cortex, the dorsolateral prefrontal cortex, and the anterior cingulate cortex. Altered connectivity and dysfunction in the anterior cingulate cortex is linked to aggression, as well as abnormal connectivity to the dorsolateral prefrontal cortex. And also the STG may play a role in social processing, which can influence aggressive behavior. Childhood aggressive behavior is related to a decreased amygdala volume, decreased sensory motor cortical thickness, and decreased global right hemisphere gyrification. The dorsolateral prefrontal cortex regulates aggression by mediating cognitive control, emotional responses, and impulse control. Increases in this activity are associated with decreases in aggression over time. The orbitofrontal cortex modulates reactive aggression, meaning it doesn't simply inhibit aggression, but influences its probability based on social cues. The anterior cingulate cortex plays a role in regulating and controlling aggression, particularly in pathological aggression, by acting as a gating function that helps to match behavioral output with contextual information and can restrain overly aggressive acts. The amygdala modulates aggressive behavior, particularly reactive aggression, by processing emotional information and initiating the fight or flight response. The hippocampus regulates aggression, particularly through connections with other brain regions like the lateral septum and ventromedial hypothalamus, influencing social behavior and potentially triggering aggression. Neurotransmitters involved in aggression and psychiatric disorders include serotonin, dopamine, norepinephrine, GABA, and acetylcholine and glutamate, as well as oxytocin. Serotonin is a major regulator of mood and behavior and is thought to have an inhibitory effect on aggression. Dopamine, a neurotransmitter associated with reward or motivation, is also implicated in aggression. Noradrenaline is another neurotransmitter involved in the fight or flight response, which may enhance aggression. GABA imbalances will particularly contribute to aggressive behavior with the relation to the serotonin relationship. And acetylcholine and glutamate also play a role in aggression, with acetylcholine contributing to the hyperactivity in the subcortical limbic region, and glutamate, being the excitatory neurotransmitter, also plays a role. Oxytocin has implications in pediatric aggression as well, as lower levels are implicated in conduct disorders. So hypothalamic and limbic brain areas include the ventromedial hypothalamus, the amygdala, and the midbrain, which play crucial roles in processing social cues, initiating attacks, and modulating aggression-related behaviors. The amygdala is a neural control mechanism that regulates neural activity related to aggression. This acts as the brain's emotional sentinel, scanning the environment for threats, and neural activity in the prefrontal cortex generally acts to inhibit aggressive behavior. Aggression regulated by serotonin neurotransmission, so regulation of serotonin release, reuptake, and sensitivity via serotonin receptors. The dopaminergic function is regulating arousal, which is necessary for aggression. Neuronal nitric oxide synthase signaling via nitric oxide gas is exerting an inhibitory effect on male aggression. There's also mutations in the monoamine oxidase A enzyme, which are associated with increased aggressive behaviors, and the nucleus accumbens promotes aggression-seeking behaviors via the modulation of activity of the lateral habenula. Here you can see the ventromedial hypothalamus ventrolateral area, which is a critical site of the generation of aggression. And also here you can see the neural circuitry of serotonin, which modulates aggression, as well as the hypothalamus, which regulates aggression and aggression-seeking behaviors, which also drives aggression. Here you can see the periaqueductal duct, and this is in the midbrain, which plays a crucial role in aggression. This is a key area which innate aggression occurs, and this happens by receiving massive inputs from the hypothalamus, especially the ventromedial hypothalamus.